Thank you. It's a great honor and pleasure to be here. Great gathering. So we'll crack on. The topic I chose for today was cognitive serverless architecture. The reason being we are living in this great maze of distributed systems, geographically dispersed organizations, collaboration. It's only fit that we talk about serverless computing today. So what I'll touch upon is what are the emerging trends and where the direction is headed in the next 2 to 5 years, and what's the data telling us, because obviously, being in computing, it's important to be data-driven, and being in the product universe, it's even more important if you want to create great products and platforms to be even more data-driven. So if you just take a look, serverless architecture, I think the key trends which are there and which are emerging on a day-to-day basis is the move from bare metal right on your bottom to functions right on the top, correct? And why is that important for us to understand? It's important for us to understand that because there is more increasing focus on business logic, as well as the focus on ensuring that there's a lot of compute associated with business logic where you need to focus on, and decreasing the control over operational concerns, which basically is automatically taken care of. And they're two separate concerns, and if we manage to separate them out, the agility and the speed with which we develop our products or platforms increase dramatically. In the old world, it was all about bare metal, OS on the bare metal, and then we moved to virtualization, and then from there, containerization, and then finally functions. And the whole world is moving in that direction to help segregate the concerns of operations vis-a-vis concerns on the business logic and functions. The other trend which is worth kind of noticing is the decreasing adoption of VM infrastructure as a service, correct? Because while we graduated from bare metal to infrastructure, infrastructure as a service, again, adoption of it seems to be decreasing because, again, it is a virtualized form of bare metal in some sense, correct? And if you look at the steady decline over 2016 all the way to 2018, you get a sense of the fact that there is a different trend which is emerging in the marketplace and in enterprises and in the startup world, correct? Which is basically gravitating towards more serverless, less bare metal, more containerization. And if you look at the stats in terms of the growth on the serverless side of some of the providers that are offering these services, you can see a steady increase. And if you take a look at AWS Lambda, for example, there's a 44% increase in adoption. So that kind of gives you a little bit of a sense that directionally it's important to understand that bare metal is a thing of the past, and where we are going to be headed is more serverless. And in addition to serverless, there is another emerging play which is coming out there and which has been steadily kind of taking place. If you look at the adoption which happened from the early 1950s and all the way to today, there's a big progression in terms of cognitive understanding, being able to analyze, being able to interpret, being able to then predict. So, gone are the days wherein, we are going to churn complex data and then predict anything. I think we need a lot more support in the support system around us in terms of our friendly neighborhood computers to be able to, give us that big, push to be able to analyze complex data structures and basically evolve our decision making. So the hypothesis that basically comes out is businesses would not be using servers in 2 to 5 years' time. And machines which are learning from the experience and penetrating complex data types and structures will help us drive associations, because that's what's important, and help reliable business decisions to be taken. And some of that is happening around us right now, here, today. Correct? So it's important for us to realize that. Moving on, I think the key things that we're kind of looking at is what is serverless? Because that brings us to the question, what is serverless fundamentally, correct? It's nothing but an architectural pattern wherein you focus on leveraging two basic core building blocks. So the first building block is nothing but back end of the service. So in the older days, you had a database, you were orchestrating the database, setting it up, manipulating it, configuring it. Now those days are gone. So if you look at Firebase and a whole host of other offerings out there, there's a complete back-end system and infrastructure that you can leverage to be able to then spin up all the great functions that you would want to kind of focus on as a business, and leverage that infrastructure and that basic service to be able to accelerate your compute in a direction wherein you're focusing again on the great complexities of what you want to do in the business domain, correct? The second part of it is code, which is running on ephemeral containers, and that is custom code that you're writing, wherein you're focusing on orchestrating and creating this whole ecosystem of different business functions which then come together and give you the compute which is necessary for you to bring your whole business idea to life. So that is function as a service. So essentially, it's these two building blocks that are coming together, and then you are iterating towards what is the serverless architecture pattern. The key things here to remember is this is always a challenge, because you're removing this dependency of something always being on in the background, because you've got to be comfortable that nothing is on. Your system, post it has used some resources, is going to just give them back to the pool, and they're going to just be used for some of the compute needs. So the two things which basically are the key things to focus on is event triggers, which basically then trigger a whole bunch of action on the back of it, and stateless compute containers, because these are stateless because they essentially used to perform a certain compute, and then they are given back to the pool, correct? And hence, being able to focus on the fact that they need to be indeed stateless is important. Overall, both of these combined then help you reduce operational costs significantly, because that's one of the big things that's always a worry with this huge ecosystem of servers, standing behind you without being utilized when you really don't need them, correct? So the whole point here is, again, the focus, shifts dramatically from having something always switched on for your consumption to switching it on when you need it, using it, and then throwing it away. So the two building blocks, as I talked about, is one is backend as a service, which gravitates us towards no ops, which essentially is your operational needs are taken care of by high-end, really complex, and really intelligent services. And the second one is you can continue to focus on writing brilliant functional code that you need to orchestrate and bring to life to help your business orchestrate all the functions that it needs and orchestrate all the business complexity that it needs. And you can focus on these functions and be able to orchestrate the functions with the backend service and bring your entire experience to life. At a broad level, I think there are 5 things to be focusing on as far as serverless computing is concerned in terms of the building blocks. The first thing is obviously there is a need for a service, as I talked about, and there are 2 aspects of the service, the backend service. Then the second thing is the functions, which I also talked about, which is the function and function as a service. Events, which are events on the back of which that you are triggering various actions and then bringing these functions to life, which then, in the end, load resources. And if you want to do something really more funky in terms of state persistence or in terms of invoking certain other APIs or sending off message payloads via event sourcing to some other system, then obviously you can add in more plugins. And that kind of is the five-pronged philosophy around serverless. And if you kind of just focus on that, I think you are starting to make the first few steps in terms of going towards a serverless universe. And on the right, if you take a look, I've put in a graphic of Apache Whisk. Apache Whisk is, again, an open source serverless framework that you can leverage to be able to do serverless computing. And obviously, IBM and Adobe and a whole host of providers are contributing significantly to it. So if you marry the concepts on the left to the diagram on your right, you can basically take a look at the synergies that are playing out. There are a few differences, which is in terms of nomenclature, where Apache talks about actions, but they're essentially functions and nothing more. In the end, is the output with the results, which are on the top right, which really matter. But the rest of the system is, again, event-driven, driven by triggers, and driven by resources, as well as the functions that you are basically invoking. The key thing to look here very closely at is, in terms of Wiz, it also talks about rules, correct? And this is where the cognitive piece comes in terms of what are the rules? What are the rules of the game? And how can you change the rules of the game? Or how can you ingest rules when you want to invoke the functions that you want to really invoke to bring your powerful deductions and powerful insights into play, to be able to then make those functions even more intelligent. So that is where the real cognitive elements of your compute come in terms of finding out how you can create these extravagant rules or these intelligent rules to basically drive the functions that you can then basically bring to life. So you can take a look at Wiz, Lambda, and a whole host of other functions, starting from Google functions to Azure functions, and play around with them. Coming down to a few examples that I wanted to share in terms of just flows and a little bit of a example of what I meant by the previous slides. So if you just look at this flow, you start, you process an event, the event activates the relevant functions. So at that point in time, you can apply your cognitive intelligence and then load up your resources and then complete the function, and that's the end, correct? Very simple. So if you look at this whole process, the key here is, again, to apply cognitive intelligence into a serverless universe. The key thing is about, where do you want to apply the intelligence? Now, most of the times, the intelligence does get applied at the functions, but there are times where, you could, bring them into play even at the point in time where you're processing events. So, example is, suppose you were doing a spell check and a hint generation function, correct? Which is very common in any kind of word processing universe. Now, in this particular scenario, if you really look at what basically you would need to do, is again very simple. You would need to start, you would need to process events. These events could then be channelized and segregated to invoke two separate functions, a spell check on one hand, a hint generation on the other hand. If you look at the spell check, you can, at a certain point in time say, hey, you know what, I want to change the spell check in terms of bring into play French or English or even Hindi or Kannada. So you just need to ingest the appropriate lex, and once you ingest the appropriate lex, you can then make the function even more evolved, and then it's just the next steps in terms of loading the resources up and then completing the function and taking it to closure, correct? So that is a very simple example, and there are more complicated ones that you can play around with. which basically will give you an idea of how you can ingest, powerful intelligence into your serverless, state of mind, I'd say, to be able to then expand your universe and go beyond the boundaries of bare metal and even virtualized machines, as well as containers. And you can just free up and use resources sitting anywhere in the world today, starting from Bengaluru all the way to San Francisco, all the way to Hong Kong, maybe. And maybe as we go on, there'd be a way for us to have compute resources on maybe the Mars or the Moon. So that's what I wanted to kind of cover today and leave you with basically my thoughts on serverless and how serverless can become even more intelligent by adding a little bit of cognitive tarka, as I say, to be able to then perform the intelligent actions that you would need to do. Correct? Thank you for your time, and do try out a few things when you get the time to basically gravitate into the serverless world. Thank you.